Hi, I'm Paul. We are doing Leetcode must-know interview questions. Today's challenge is search in rotated sorted array. All right, so we've got an integer array nums. Oh, rating medium. This, I don't know. To me, this is on the high end of medium. Um, it takes some thought actually to figure out how to do it, and then once you've figured out how to do it, even the implementation is a little bit harder. It's a binary search problem, but it's a little bit harder to implement than a typical binary search. So anyway, you get an integer array nums sorted in ascending order, distinct values. Prior to being passed to your function, nums is possibly rotated at an unknown pivot index, k. K is somewhere between 1 and the length of nums, such that the resulting array is, that's a little bit confusing to look at it that way. But here's an example. For example, this array might be rotated at pivot index 3. And so what that means is pivot index 3. That means that these numbers here will be rotated to the beginning of the array. And then what you'll wind up with is this. Okay? So we are given the array nums after a possible rotation. We're given an integer target, and we are supposed to return the value of, the index of target if it is in the array, or -1 if it's not in the array. You must write an algorithm with O, log, and runtime complexity. Okay. Yeah. Well, let's look at how this would work. Let me get a pen here. So the numbers that you need for binary search, you need a low, which will start out at 0. You need a high, which will start out, at this case, the index 1, 2, 3, there's 7 elements, so the high index is 6, and mid, which is low plus high divided by 2. So in that case, 3. I don't like this example because it doesn't really make it clear. Well, if you rotate an array and you pick the middle element, at least 1/2 of the array, that is the elements either to the right or left of the middle element, at least one of those will be sorted. Now, it's possible that the other one will not be sorted. This one is a little bit unfortunate in that both of them, if you pick the middle element, both of the arrays are sorted. 0, 1, 2, 3, 4, and the target is 0. Okay. Yeah, it's almost kind of it's kind of arbitrary. Let me think about this for a second. Okay, anyway, here's how it works. So we will pick the middle element at index 3, which is right here, 7. Oh, and by the way, this, there is a, it's a recursive algorithm, and the base case, other than finding the target, the base case would be if, as long as low, as long as low is less than or equal to high, then we're going to keep going. If low becomes greater than high, then we stop and return -1, meaning we didn't find it. All right, in this case, so we have low, we have high, we have mid. The target is 0. Is the mid equal to 0? Is 7 equal to 0? No. All right. In that case, let's see. In that case, what we want to find out is, first, is the subarray to the left of mid, is that in order? So we're going to look at, is the sequence of numbers from low to mid, or to one less than mid, is that sorted? And in this case, actually it is. That would be this, 4, 5, 6. The next thing we look at is the target in that range. In this case, 4 to 6. And it isn't. 0 is not in there. So we're going to toss that. Okay? We're tossing it, and we are going to do a new binary search on the numbers to the right of mid. So how do we do that? So we adjust low to be mid plus 1, which is 4. And then we have to calculate a new mid. 4 plus 6 is 10, divided by 2 is 5. All right, where is our new mid? Let's get rid of that. The new mid is index 5, 0, 1, 2, 3, 4, 5, right here. Okay. So let's see. Is the target equal to mid? No, no, it isn't. The numbers to the left. Well, now we got to keep in mind that we have eliminated these numbers now. So now we look and see, is the array to the left hang on. All right, is the array to the left of mid, is that sorted? Yes. Is target in that range? Yes. So now we do a binary search on the elements to the left of mid. How do we do that? All right, so we have nums, we have low. We're going to have to adjust high. High becomes mid minus 1. Yeah, that's right. So that becomes 4, actually. We recalculate mid. 4 plus 4 is 8, divided by 2 is 4. All right, we have a new mid. Let's get rid of this. Here's the new mid. All right, is target equal to mid? Yes. In that case, we just Wait. If, yeah, then we return mid. Target is equal to mid, so we return mid, and mid is 4, which is the output that we're looking for. All right, so yeah, let's see what that looks like with an implementation. The implementation is a little bit, oh, I don't want to say uglier, but it's a little bit more complex than a typical binary search implementation. All right. All right, here it is. So we got public int search. We want a binary search. We want a recursive binary search. We need a little bit more information than just nums and target. So we will return a new, we will return the result of a new binary search method that we're going to write. Binary search. Binary search is going to need nums. It's going to need the array. It's going to need the low element, okay? It's going to need the high element, and it's going to need the target, okay? Right, let me copy that. This can be a private function, private. This is going to return an int, private int, binary search. Input is nums, which is an int array. It's going to have low, it's going to have high, and it's going to have target. This is, let me scoot this over a little bit. So I don't want to wrap target. All right. And I actually don't want this thing. Is this actually visible? I don't know. Okay. So again, if this is going to continue until, as long as left is less than or equal, or left, not left, low, is, as long as low is less than or equal to high, we're going to keep going. But if low becomes greater than high, then the indexes have crossed over. We didn't find anything. We're going to have to return -1. Why -1? Well, it's over here actually. -1 if it's not found. All right. We need mid. Let mid equal low. Let's do it like this. Low plus high divided by 2. All right. If target equals nums at mid, it's our lucky day. Should be here. And then we will return mid. We're returning the index. We don't return the number, we return the index. All right. So, again, we've got, as I said, the first thing that we're looking at, nums low. If nums low is less than nums mid, then we have a sequence there to the left of mid. That is a sorted array. And actually, no, we need a little bit more than that. It's a sorted array, and target is less than nums mid. Okay, good. So what does that mean? That means that we have a sorted array and target is in the sorted array. So now it's just a typical binary search. Return, did I still copy that? Yes, binary search. Again, the input is nums. The input is low. Input on the high side is mid minus 1. And we send in the target. Okay. Wait. You know what? I got to do this in 2 steps. Let's do it like this. We have a sorted array. All right. If yeah, no, we have to do it like this. If nums low is less than or equal to target, and target is less than nums mid. Okay. That tells us that we have a sorted array and target is in the sorted array. It's greater than or equal to the left-hand element. It's less than the mid element. We already know it's not equal to mid, so it's in there. So we can binary search it like that. Okay? If that is not the case, that is, we already know we have a sorted array, but target isn't in it. So that means we've got to deal with the elements to the right of mid. So let's just copy this. Okay, this is telling us that the target is not to the left of mid. So return binary search nums. The low is going to go to mid plus 1. We are throwing out the low half of the array. All right. Now what? If nums low is less than nums mid, if that's false, then the elements to the left of mid are not sorted because we rotated it. Again, I wish the example didn't have a sorted array on both sides of mid to start with, but it is possible if you rotate an array and then find the middle element that one side of the array is not going to be sorted. So if we get here, that means we have, let's see, nums low is not less than nums mid. Okay, so the elements to the left of mid are not sorted. Okay? That means the elements to the right of mid are sorted. Let's put that here. All right, actually, that's not quite right either. We got to do it like the same thing in reverse. All right, if we get here, we have a non-sorted subarray to the left of mid. We have a sorted array to the right of mid. So what we would like to know is, what about that sorted array to the right of mid? Is that, does that contain the target? Okay, target less than or equal to nums high. All right, if that's true, if the target is greater than mid and less than or equal to the far right element, then yes, target is in the array to the right of mid. So then we can do just a typical binary search. We have a target, we have a sorted array, so we send in nums, we send in the low index, which will be mid plus 1, we send in the high index, and we send in the target. All right. Else. Okay. So this really should be just like this. If target is not in the, if we get here, it means target is not to the left of mid. So if target is not to the left of mid, oh, there it is. If target is not to the left of mid, then we have to binary search, we have to binary search the subarray to the left of mid, even though it's not sorted. But that's okay because thanks to all these if-else statements, we know how to handle a binary search on a non-sorted array. So I think we have everything that we need here. Let's go ahead and try to run it. Compile error if what? 18, line 18. I think I closed too many things here. Yeah, I guess I did. All right, yeah, that shouldn't be there. And then why don't I go ahead and indent the rest of this? Indent that, but now I probably need another bracket here. I don't. Hang on a second, I gotta count up my brackets here. Okay, I do see one problem here. That should be, there should be an open bracket here, and I really think there should be a bracket here. Okay, that looks better. All right, let's try it again. Compile error. What? Can't find symbol let. Again, on line 11. Okay, let me take a look. Okay, sorry. Yeah, I've been switching back and forth from TypeScript to Java, and my declarations get messed up. Oh, there we go. Accepted. All right, let's go ahead and submit it then. Run. Is anyone watching me do this, like in Java, and writing let and going, no, no, no? Okay. So that is, okay, oh, accepted. Accepted. Did I just submit that? Usually the submit shows up over, okay, there it is. Wrong answer. Okay. All right, so that's fixed. I'll tell you what I changed. This used to be if nums low is less than nums mid. And as I was writing that, I'm thinking, well, the numbers are distinct. So I don't know. I was thinking in terms of the full array. So like, well, the numbers are distinct. So nums low can't be equal to nums mid. But then it occurs to me as the subarrays get smaller that yes, you could have a subarray of size 1 and nums low could equal nums mid. So change that to greater than or equal to, and it does work. Okay. And that's it. Analyze complexity. Log n is what we were asked to provide. That's what we have. Log n. Okay. Thanks for watching. Hope you enjoyed it. Please feel free to subscribe, like, comment, and see you next time.